Currently, there is an asteroid the size of the Empire State Building on a path that will bring it closer to Earth than even our own satellites. This is set to happen on April 13th of 2029. You've probably heard of this many times in articles over the past few years. But we are going to give you some information that maybe you haven't heard. In 2004, when NASA first spotted it, they calculated that it had a 2.7% chance it would hit us. That's the highest impact probability ever assigned to a tracked object in the history of planetary defense. It got rated at a level 4 on the Torino scale, a scale that only runs to a maximum of 10. Nothing before it, and nothing since, has ever been rated above a 1. They named it Apophis after the Egyptian god of chaos. And for 3 days in December of 2004, scientists at NASA, at ESA, and at every major space agency on the planet genuinely did not know whether this thing was coming down on top of a city, on an ocean, or nowhere at all. This is what happened next, what very nearly happened in 2029, and what's actually set to happen in 2029. And why the objects we haven't found yet matter more than all of that combined. Let's take a step back and we'll start with the basics. Let's start with the panic, because at the time it made the most sense. A 340-meter asteroid, roughly Apophis' size, hits with the energy comparable to that of 1,000 nuclear weapons going off all together. On land, it will flatten everything near the point of impact, vaporizing instantly, and sends a shockwave across the continent with enough debris kicked into the atmosphere to affect global temperatures for quite some time. However, if it strikes in the ocean, and that's where most of the planet's surface is, it throws up a tsunami big enough to redraw entire coastlines. That 2.7% number was NASA's own model, built from whatever tracking data existed at that time. And for 3 days, it stood as the official figure given by NASA. And then it started to move. I don't mean it grew legs and walked away. What moved it wasn't new technology. It was actually old film. Astronomers dug back through earlier telescope archives and found pictures of Apophis taken months before anyone had identified it as Apophis. Once that older data got folded into the orbital model, the calculation sharpened fast. The 2.7% that was originally given dropped, and by 2006, it was down to 0 for 2029. No impact at all. That's held ever since, and it still holds today. Now, most of your coverage, all of the articles and videos that you've ever seen, have all stopped right there. We're not going to do that because, well, it doesn't do the science justice. And, well, the answer doesn't actually stop right there. It shouldn't, because clearing Apophis for 2029 was never the same thing as saying it would drift by at a comfortable distance. It's not going to. Apophis will pass within roughly 20,000 miles of Earth. Now, to me and you, that number does not sound all that close. But in the bigger scale of planets and asteroids, 20,000 miles is the equivalent of walking next to someone on a busy sidewalk. GPS satellites sit at about 12,000 miles higher than that. For a stretch of time, this asteroid will be moving through the same general layer of space that our own satellites occupy, closer to us than the very systems that run navigation and communication for us daily. A pass that close doesn't simply leave the rock unbothered either. When something that size gets near a planet, gravity reaches out and bends its path, and that bend can be calculated to a tight margin. Researchers found a narrow patch of space, less than half a mile wide, that picked up the name gravitational keyhole. You may have just heard this referred to as the keyhole. If Apophis had gone through that exact patch during the 2029 flyby, Earth's own gravity would have turned it into a new course, and that lined up for a possible impact in 2036 of the same date, April 13th. For years, that stayed as a real possibility. It was small, but real. It wasn't ruled out until much later in 2021, when radar from NASA's Goldstone Deep Space Complex nailed the orbit down tight enough to close the keyhole for good. NASA's current read is that Apophis isn't a threat for at least the next 100 years. So the 2029 flyby isn't itself dangerous, and the keyhole is shut. This isn't a warning video for you about Apophis. What it is very rare. This is close to the best look we'll ever get at what happens when a planet's gravity grabs hold of a quarter-kilometer rock and reshapes it in real time. Nobody has gotten the chance to watch that happen up close before, and this time it won't only be instruments doing the watching. On the night itself, anyone in Africa, Europe, or Western Asia can walk outside and see Apophis with nothing but their own two eyes. It'll look like a faint star, except moving, drifting across the background sky over the course of the night. Over 2 billion people will get a clear shot at it on a clear night. No hazardous asteroid has ever been visible to the naked eye during a close pass-by before this one. Now, that is the part you, or other people, will get to see. The other part happens in orbit. The European Space Agency is fast-tracking a mission called Ramses to reach Apophis before the flyby, so it can watch what Earth's gravity does to the asteroid's shape and spin and structure while it's happening. NASA's OSIRIS-APEX, already up there, will catch up with it right before. There's also a real question among scientists about whether the stress of the encounter could shake the surface loose, something like an asteroid version of an earthquake. The models say it's possible. Nobody has ever actually seen it happen. In 2029, however, is when that gets to be tested. Right now, there are more than 2,300 known objects classified as potentially hazardous, big enough to do real damage if they were to ever touch Earth, on orbits that are close enough that we track them constantly. Those ones are fine. We've got eyes on them. You don't have to worry about that. What is a little disturbing is the ones we haven't quite found yet. Those are the real issue. In February of 2013, a meteor came in over Chelyabinsk, Russia, with zero warning. It came from the direction of the sun, which happens to be the one stretch of sky no ground telescope can really watch, because you can't pick anything out against the glare. The object itself was only about 20 meters across, a sliver of Apophis' size, and it still hit with roughly 30 times the energy of the Hiroshima bomb. Windows shattered in 6 cities. Over 1,500 people got injured, and nobody saw it coming because nobody could. You can actually find videos of this incident on YouTube. Apophis is 17 times wider than that rock. Imagine what would have happened if Apophis had been coming from the same direction. Now, we've been watching Apophis for 25 years. Chelyabinsk got none. The gap between those two outcomes was never really about size. It was about how much warning we had before we could do something about it. That's the real story behind April 13th, 2029. It's less of a near miss to be scared of, more of a fully observed dry run for a kind of event we still aren't great at seeing coming. Maybe as science progresses more, we can truly see these threats coming, but as it stands right now, we are unable. And the dry run only really covers what's already on our radar. For every object we are tracking, there's an unknown number we're not. Ones with no old footage sitting in an archive somewhere. No decades of warning prior. No keyhole calculation to close out. Somewhere past what our telescopes can currently reach, or just beyond the sun where we can currently see. On a path that nobody has plotted, the next one is already moving. We won't know where or when until it shows up. All further information will be pinned below if you want to dig into the orbital mechanics yourself. And as always, guys, remember, stay happy and stay safe.